For example, in this case let me again create one more vertex as a start vertex. Let's say somewhere here, and let's say somewhere here. This is the end vertex. Visibility should be off. Apply, and now I'll go to face creation, skin surface, and I'll again say one edge from every rib. So one edge from rib 1, rib 2, one edge from rib 3, rib 4, and remaining will not matter. I can select in this way, and now I'll say this is my start vertex, and I'll say apply. Sorry, the connected was not active, so definitely it will not create a good surface. So I'll activate connected edges first, because edges are not simple. One edge from one rib, second rib, one edge from third rib, fourth rib, then fifth, and then sixth. Connected is active, and then let's say this is the start vertex, and apply. I don't have any end vertex, so apply. If you see, what it does is, the face creation is same here also. It is up in this particular region, the face creation is same. Only thing what happens is, the start of this face will be this particular vertex that you have selected. So all the ribs will be starting from this particular point. Similarly, you can provide what is the end point. Again, I can say connected edges has to be active, then one edge from one rib, rib 2, rib 3, rib 4, then remaining will not matter. Activate connected, and say end vertex is this, and say apply. If you see end vertex, the effect of end vertex is all the ribs will go and end at this particular vertex. Similarly, you can activate both, you can give both. So one, first rib, second rib, third rib, fourth rib, then remaining doesn't matter. Then this is the start vertex, this is the end vertex, and then apply. If you see, all the ribs are starting from this point, and all the ribs are also ending at this particular location. So this is the effect of start vertex and end vertex in creating a skin surfaces. So this is some overview of summary of the skin surface. It is generally used for topologically parallel edges. Topologically parallel edges means they need not to be parallel, but topologically they have to be parallel, not non-intersecting edges. Basically, the end point of the edges could be same, all the end points. So in this case, this also I can create the surface, and I can also create the surface, and it creates the surface in this particular way. You can activate connected edges for the ribs which are formed by chain of edges. So you can also give start vertex as well as end vertex. The second method of creating surface is the net surface. This is same as that we are creating a net, and then on top of that we are putting a wooden plank. It creates the four-sided face from these two sets of logically intersecting edges. It means if you have two sets, one is called as U set, and other is called as V set. If they are logically intersecting with each other, it will create the face. So in this case, all these direction edges are called as U sets. All these directions edges are called as U sets, and all these direction edges are called as V set, and they are intersecting with each other. And then what it does is, it creates the fits the surface at the intersecting regions. So two set of edges that defines the face, at least two edges in one set. There should be at least two edges in the one set. That is the rule from Gambit side. So again, as I said, you give the logical intersecting edges, U edges. These are all called as U edges. These are all called as V edges. Give V edges, and then what it does is, whatever the intersecting region which is there, it will create the face in that particular intersecting region. That is what Gambit does. Now if the edges are not completely intersecting, what it does is, it trims those edges after creating a face. So for example, in this case, let me create some vertices again split edge. Let's say this edge here, this edge here, and this edge here, this somewhere here. So I splitted this, and then let me create the edges. should be nerves edges, this vertex, so what I have done is I have created some kind of a net. Now again go to face, net surface, u direction edges. So let's say this is my u direction, so I'll say all these are u direction edges, but they are, let's see, these are u direction edges and these are v direction edges. But it will not allow you to have the edge chain loop. So I'll say again, I'll create some vertices and I'll create some edge net of the edges. Visibility should be off, on, and then let's say I'll create some random vertices. Visibility should be off, edges, nubs, this is one u edge, this is another u edge, this is third u edge, and this is fourth u edge, first v edge, second v edge, let me see if this works, third v edge, fine. Now I'll go to face, then net surface, u direction edges, let's say 1, 2, 3 and 4, these are u direction edges, these are v direction edges, and I will say apply. If you see, what it has done is it has created a face by using u and v direction. Alright, so this tolerance is again same as how the boundaries will be away from your particular edges that you have selected. Now what if I do this, like let's say if I select only these two edges, or if I only select 1, 2 and 3 edges as the u direction edges, I have not selected this edge, and then this and this edge as a v direction edge, and if I say apply, if you see, the face which is created is only this. So what it does is only overlapping region will be the face, overlapping region, in overlapping region only it will create the face. So that is what Gambit does. Face will be truncated if any edge length in one direction exceeds the edge length of the first or last edge in the other direction. So if I have selected, let's say u2, u3 and u4, all the edges will be truncated after this u2, or maybe if I have selected only v1, v2 and v3, all the edges will be, u edges will be truncated from after this v3. So that is nothing but it truncates the face if they are not overlapping. A tolerance value is the maximum allowable distance between any edge and the resulting face. That is what I said. It is nothing but how your boundary of the faces will be close to the edges that you have selected. This is again one important you can say operation available in Gambit, which is nothing but create face from vertex row. It creates the four-sided face from a series of vertices that you have given. What it needs is it needs the sequence of vertices that defines the face, integer multiple of number of vertex rows. We'll see what is it, the number of rows of the vertices to be used, the method used to fit the curve, interpolate or approximate. That is what it does. For example, let's say I have these vertices. If you see, if I have only vertices, in this case I'll delete all the faces without lower topology, and again I will delete all the edges without lower topology. So I have what? I have just set of vertices, and now I want to create a particular face out of it. Then what I can do is I can give these vertices. So what Gambit does is Gambit fits the surface using different it creates the four-sided face. So first and last row forms the edge. It means if I have given set of vertices, what it does is the first and last row forms the edge. So let's say, for example, in this case I will go to face creation, and let's say vertex row. Let's say I have selected all the vertices. So let's say I have selected all the vertices. Number of rows, let's say there are 3. Number of rows 3, and I will say apply. So if you see, what it has done is it has created very random surface. So again I will go here and then sort. So number of rows 1 2 3 4, let's say number of rows 4, apply. So if you see, it has created a face. So what it has done is, how many vertices I have given in this case? 1 2 3 4 5 6 7 8 9 and 12 vertices, right? And I have given number of rows as 4. So every edge will be made up of 3 vertices. So first 3 vertex will be the first edge, the last 3 vertices will be the last edge, and the vertex, the start or the first vertex from every row will be one edge, and the last vertex from every row will be another edge. So in this case, what it does, first and last row forms the 2 edges, the first vertex specified in each row forms the one edge, the last vertex specified in each row forms the another edge. This is the way the 4 edges will be created and the faces will be created. For example, in this case, how many vertices I have? I have 12 vertices. So 12 vertices, the number of vertices on in every row or for every edge should be same. So 12 vertices, either I can have 4 edges made up of 3 vertices, or I can have 3 edges made up of 4 vertices. So let's say I have said 12 vertices are there, and I am going to say 3 rows. 3 rows is nothing but every edge will have 12 divided by 3, 4 vertices. So the first 4 vertices which I am going to select will be the first edge, in this case R11, R12, R13 and R14. This is the first edge it is going to create. The last edge will be again the last 4 vertices. So R31, R32, R33 and R34. This is the last edge which it is going to create. And again, if you divide the number of vertices that you have selected into 3 rows, every row will have first vertex and the last vertex. So the first vertex will be the first vertex of every row is the third edge, and the first vertex of every last vertex of every row will be the last edge. So in this case, what it has done is, first 4 vertices, vertex 1 2 3 4 will be one edge, it will fit one edge. Last 4 vertices one edge, first, second, third and fourth. Last 4 vertices is the another edge, and again first vertex of every row. So again first vertex, then fifth vertex, and then ninth vertex. So this is the third edge, and then this is the fourth edge. So the way it has created face is this. Similarly, again if I give same 12 vertices but the 4 rows, so in this case the first vertex will be, so in this case the first vertex will be, or the first edge will be, because there are 4 rows, the first edge will be 3 vertices in a given row. So first vertex, second vertex and third vertex is the first edge, then 10th vertex, 11th vertex and 12th vertex is the second edge, and again the first vertex from every row and the last vertex from every row. So that is nothing but the 4 edges it is going to create, and it is going to create the face using those 4 vertices. This interpolate and approximate, you imagine that it is going to fit the NURBS surface, it is going to create the NURBS curve. Interpolate is nothing but it will try to pass that NURBS curve, which is nothing but the boundary of face, through the vertices, and approximate is nothing but there is some tolerance. So the curve, NURBS curve which is going to be created, that will deviate from the vertices by the tolerance value you have given. So this is about the vertex row. The next method is sweep edge. you can create a face by sweeping a edge along a path or maybe along a given edge. The next method of creating face is sweep particular edge in a given direction. So it creates a face by sweeping one or more edges along a given specified path. What it needs a profile. A profile is nothing but the edge to be swept, and it needs a path along which the sweep operation will be carried out. The path can be edge or a vector. It is same as creating edge by sweeping particular vertex. This operation is same as that. In this case, only thing is it is going to sweep a edge and create a face out of it. We can also provide an option of with mesh. In this case, this is applicable only for meshed edges. If the edge is meshed, at the time of sweeping it will create a face and the mesh on the face also. There are two type of sweeps, again one is rigid and other is perpendicular. So let's have a look at this particular operation. So sweep profile, the edges can be straight or curved edges, real or non-real edges, or may not be connected to each other. It means this profile that or the edge which you want to sweep, that edge can be real, non-real, or they cannot be, they can be disconnected edges. The profile edge cannot be parallel to the sweep path, that is the constraint. If the profile edge, the path along which or the edge which you want to sweep, that edge should not be parallel to the path. In that case, it cannot create the face. Sweep path can be edge or the vector. If it is edge, the shape of the face depends on the shape, length, and the sense of the specified edge. Vector, if it is a vector, straight line path possessing the magnitude and direction. So vector is nothing but you have to provide the direction as well as you can provide the magnitude. So this is with mesh operation. If you have selected this as a profile and this as a path, if profile and path both are meshed, the mesh on this particular face is fixed. If path is not fixed or if path is not meshed, then what it will do is it will use the default mesh size which is there in Gambit. So this is nothing but with mesh operation. Again, this is a rigid and perpendicular sweep. In case of a rigid sweep, what it will do is it maintains the orientation of the profile with respect to the global coordinate system. It means if this is the profile, this profile, the orientation of this with respect to global coordinate system will be maintained and it will be swept. So the orientation will not be changed. So if this is the straight profile and straight path, this is the face. If this is the curved profile and straight path, this is the face, and this is the curved profile and curved path, this is the face. In case of a rigid sweep, what it does is, in case of a rigid sweep, it maintains the orientation of this profile with the path, not with the global coordinate system. So this is again a path and a profile. This is profile, this is path. So this is going to maintain if it is rigid sweep. So if you see, this is vertical and here also it is vertical. This is maintained with respect to global coordinate system, and if it is a perpendicular sweep, this is maintained with respect to the path that you have selected. So this is the difference between rigid and perpendicular sweep. There again difference of where that particular path is located, if path is on the profile or if path is not on the profile. So the first case is this is the path and this is the path, this is the profile, this is the path is on the profile. So this is the face which is created. Again, this is the path, this is the path, this is the path, this is the profile, again path is on the profile. So this is the face which is created. So if path is on the profile, then it will not do anything to the path. It will maintain the path at the same location, and in fact the path will act as one of the boundary of the face created. But if path is not on the profile, if in this case, if you see, this is the profile and this is the path. Now depending on what are the options that you have selected, like in Gambit there are some default options. So if depending on the value of the default, it will copy the path first on the profile and then it will create the face, and by default the path will be copied at the center of the profile by default. So in this case, if you see, this is the profile, this is the path. first is this path is copied at the center of this, and then the sweeping operation is done. But depending on, as I said, what are the defaults, so geometry, volume, sweep, path alignment, if that is 0, it moves the path to the nearest point of the profile. If it is 1, it moves the path to the midpoint of the profile. In the sense, if the default is 0, in this case this path will be copied at the nearest point, which might be A, and then the sweeping will be done. If it is 1, the path will be copied at the center and the sweeping will be done. Geometry volume sweep method control the shape of the created face at the, we will see this. So let's have a look at the sweep operation first. So let's say I have created a face and then I want to create a volume out of, I have created this particular face, and now I want to create these faces by using sweep operation. So I will go to sweep edge. Which edge I want to sweep? Let's say I want to sweep this particular edge in z direction by 10. So if you say 0 0 0 and 0 0 10, I will say rigid sweep, apply. So I got this face. At the same time, I can actually select more than one edges. So this is first edge, second edge, third edge and fourth edge, and again same, I will say apply. If you see, I got 4 faces. So I got these 4 faces. Or I can also select the edge. So let me delete some faces. So let me delete all the faces without lower geometry. Fine. Now what I can do is again sweep edge. I will say which edge I want to sweep. Let's say this edge, along edge, this edge, and apply. So what I got is I got this particular face. So I can also select edge as the sweep path. So again I will say this edge and this edge, and I will say reverse the direction, apply. Now this face is created. So this is the way the sweep operation will work. And now if I say okay, this is the edge, for example, if I say this is the edge and this is the path, apply, I got this face. And if you see, this is the effect of path being on the profile. So right now the path is on the profile, so definitely this face is created and I activated rigid. Now in this case also perpendicular and rigid will be one and the same. Now let me mesh this particular edge first. So I will say okay, mesh the edge, mesh this particular edge, and then if I go for sweep operation and with mesh, I will say sweep this edge along this with a mesh. So if you see, I have activated mesh. So all these sweep faces are always mappable. They are always 4-sided faces. There is always opposite face and all, opposite edge and all. So they are always mappable. So it will always create a very nice map mesh in the sweep face. So this is the effect of with mesh operation. And again in perpendicular there is something called as draft and twist. We will have a look at those particular operations. The defaults which I was talking about, if you go to edit, defaults, then geometry, what is the default? So geometry, volume, sweep, path, alignment. If you go to geometry, volume, and sweep, path, alignment. If you see right now sweep path alignment is 1. So what it says, 1 is nothing but move sweep path to the mid of it, don't move the sweep path. That is nothing but sweep path alignment. That is sweep path alignment method. So depending on what is the default value you have given, it will do moving up the path on the profile. Geometry volume sweep method, it controls the shape created at the end of the sweep path. 0 or 1 maintains the original profile oriented through the sweep orientation. So it does this. For example, imagine that this is the face which is getting created after sweep operation. Now if the sweep method is 2, it will be original face. I mean in the sense, if the sweep method is 0 and 1, This is the original face, the way standard sweep operation works. If the method is 2, then what it does is, first is it it creates something called as truncation plane, and that plane is perpendicular to the path, and then what it does is it truncates the face which is created by using this particular plane. So if you see the geometry of this and geometry of this particular object is different, or face is different, what it has done is it has truncated this particular face somewhere here, and by using a truncation plane, the truncation plane is perpendicular to the path. So I don't know, maybe many times we use a standard sweep operations, sometimes yes, with mesh also, but these are some advanced operations which are available. You can always explore those operations. So this is again effect of truncation plane. So again it truncates the plane. If the sweep method is 2, it creates the truncation plane, it truncates the face by using the truncation plane. This is again different options in perpendicular sweep. One is draft and other is twist. What draft does is, if imagine that you are going to create a standard face. For example, in this case, let's say if I am sweeping this particular circular edge along the axis, I am going to get this particular face. Now this draft does what? It deviates the face created by using the angle that you have given. So draft is nothing. If it is a positive draft, it will be kind of expanding cylinder. If it is negative draft, it will be kind of contracting cylinder. So it deviates the face which is going to be created from the standard face by the angle which you have given. So this is the effect of draft. And again this is the effect of twist. The standard sweep operation doesn't twist the edge at the time of sweeping. The twist operation, what it does, while sweeping along a path, it always it twists this particular face on about that particular path, using path as axis, and profile is getting swept, or it will be revolved around that axis by the angle that you have provided. So this is nothing but twist operation. So these are the standard forms for sweeping the edge. So sweeping edge is nothing but face, create a face by sweep edge, you provide the edge, you can provide more than one edges. The path can be edge or it can be a vector. Vector is nothing but a general vector definition form. Then you can provide with mesh if the edge is meshed. The type of the sweeps are rigid or perpendicular. In case of perpendicular, you can provide draft and twist angle, and you can create a face by using sweep operation. So this is about create a face by using sweep operation. Another method is again a revolve, same as create a edge by revolving a vertex along axis. What it needs is, it needs one or more profile edges to be revolved, it needs the axis of revolvation, and it needs the angle through which the edges are revolved. With mesh option is also available. So again it creates the four sided face, face made up of 4 edges. One is the profile edge, one edge is the profile edge, one is the projection of the profile edge, and the 2 edges formed by revolving the edges. So what it does is, it takes the edge, and it revolves the edge along a given axis that you have provided. If this edge is meshed, then definitely this particular face you can create a mesh at the time of revolve, because that is always mappable face. So axis of rotation, again axis of rotation is a general vector definition form. Angle of rotation, same as the rotation operations that we have seen. With mesh option is this, I mean if this particular edge is meshed, you can revolve this edge and create a face mesh also. But this is one effect of you can say mesh, revolve with mesh operation. If the edge end point is on the axis, then definitely it cannot create a quadrilateral mesh. So what it does is, it creates one triangular mesh layer, and then remaining will be a quadrilateral mesh. So that is the effect of, if the one end point of the profile is coincident with the axis of rotation. So that is the effect of this particular if the profile that you are going to rotate is one point of it is on the axis of rotation. So this is the typical revolve edge. It uses the right hand thumb rule. So this edge revolve it, create a face, or this edge revolve it, it will create a face. And this is the typical form. So this is the operation of revolving edge. So you select the edge which you want to revolve. For example, let's say I want to revolve this particular edge. Angle should be, let's say, 180 degree, and the axis should be, let's say, positive y. So I will say positive y, magnitude will not matter, and apply. So what I got is, I got this particular face. So I got this particular face by revolving this particular edge along the y axis. At the time of revolution, I can always specify, okay, I want to revolve it with mesh. So I will apply, I will activate with mesh, and then angle should be, let's say, again 180 degree, and the axis of revolution is y. So what I got is, I got a mesh at the time of revolution also. So this is nothing but revolve edge. So these are the methods by which you can create a face in Gambit. One is wireframe along with some advanced operations. In real face there are some advanced operations, advanced covering operations, virtual face, host, and tolerance is there. Parallelogram, it will ask you vertices, origin, inclination, and base vertex. Then again polygon, it will ask you number of vertices. Then a circle, it will ask you again vertices. So there is center and 2 point and 3 point circle, it will create a circular edge, then face out of it. Ellipse is nothing but again center, major, and on edge vertex it will ask you. You can also provide the angle. First is it creates the elliptical edge and then elliptical face using that particular edge. Then similarly you have a skin surface, which is generally used for logically parallel edges. If the what it does is, it fits the surface using the ribs. The rib can be made up of single edge or more than one edges. If they are more than one edges, activate connected edges. The edges has to be connected to each other to form a single rib. Net surface is nothing but logically intersecting edges, u direction edges and v direction edges. Provide those edges, it will create a face out of it. Vertex row is nothing but you provide the number of vertices and number of rows. Number of rows are nothing but let's say 12 vertices are there. How many edges that you want to create? So 12. Number of rows, if the number of rows are 3, then the edge will be made up of 4 vertices. So this is the way this vertex row will work. Sweep edges, you can create a face by sweeping one edge along a vector or maybe another edge which is present in the geometry. At the time of sweeping, you can also say with mesh, and again rigid and perpendicular operations are available. In case of perpendicular operation, there is a draft and twist. And this is nothing but last operation is revolve edge along a given axis with a given angle. So axis is again a general vector definition form, and you can also activate with mesh. So these are the different methods of creating faces in Gambit. Now you can always create a primitive faces like rectangular, circular face. So these are the methods. Let's say rectangular face 10 by 10, I will say create 10 by 10 rectangular face. You can always provide the orientation of that. XY centered, right now I have created XY centered, means the origin the location of this face is the center of this face will be center of this particular xy axis, or the intersection of xy axis will be a center of. So this is nothing but centered xy, positive xy. If I say apply, this is actually in a positive xy. If it is in positive x and negative y, so you can create this kind of. So you can give what is the dimension and then what is the orientation of the face. You can always give that. So this is nothing but rectangular face of given size. Circular face, again circular face, you give radius equal to whatever, maybe let's say 5, and then the plane in which it is going to be created. The origin of the this particular circular face is always a center or centroid of the coordinate system. So you create a circle here, and then maybe you can move this circle at another location. So again there are different planes in which you can create the circle. So this is the standard circular face that you can create by direct circular face. We need not to go for creating a circular edge and then face. Internally it does that, but we need not to do create the edge creation and then maybe go for face creation. Again, ellipse, it asks you what is the radius 1 and radius 2, and in the plane in which you want to create the ellipse, so it will create the elliptical face using those two radius. So these are the primitive faces which you can create in Gambit. So again, create a real rectangular face, width and height is needed, and then a coordinate system and the direction in which you want to create it. So this is the create rectangular face form. You can also create a circular face. Internally it will create circular edge and then face out of it. It needs the radius, the coordinate system, and the plane in which you want to create this circular face. Then this is the form for circular face. Similarly, you can create a elliptical face. So what it needs is, it needs the radius 1 major axis of the ellipse and radius 2 minor axis of the ellipse. Internally it creates elliptical edge and then elliptical face out of it. It needs also the plane in which you want to create the ellipse. So this is the create elliptical face form. So these are the only operations in Gambit by which you can create a faces face geometries in Gambit. So now let's have a look at the Boolean operations in Gambit. So there are different Boolean operations that you can do. One is subtract, unite, and then intersect. So imagine that these are the two faces, face 1 and face 2. When you say unite, what it does is, using these two faces it creates the it creates only one face, and whatever the overlapping region is there, it is going to delete one overlapping region. So this is a standard unite operation. Subtract does what? It subtract one face geometry from another face geometry. That is what subtract operation does. And intersect does what? Intersect keeps only the geometry which is intersecting, overlapping, and then it deletes the remaining geometry. So these are the three operations that you can do. So if you go to Gambit and if you have two surfaces, for example, I'll create two rectangles. So standard, let's say 10 by 10, xy centered and positive xy, apply. Now if you see, these are the two faces. Now I'll go to Boolean operations. Here Boolean operations are there. Unite, so I'll say this face and this face I want to unite them, apply. So what I got is, I got a new geometry, only one face. And then if I say subtract, from this face I want to subtract this face, so what I got is, I got this geometry. And then if I say intersect, I want to intersect these two faces, I got only this geometry. So this is the way these three operation works. In fact, there are different things that you can do. When you say unite, let's say I want to unite this face and this face, let's say I want to unite these two faces. Whenever you say unite, then what it does is, it deletes the two original faces and new face which will be created, which is nothing but a union of these two faces. Now if you activate retain, then it will create three faces. Two original faces will be retained, and again new face will be there whose geometry is like a union of those two faces. So this is nothing but retain. By default it deletes the original faces and it retains. By default it deletes the original faces and creates only one, keeps only a new face which is going to be created. Now there are two operations, one is virtual and other is real. We'll have a look at those operations. So unite face, unite two or more faces to create a single face. Type of unite that you can have is virtual and real. So real unite, unites real faces that overlaps each other. One face for each set of overlapping face it will create. Virtual, it unites real or virtual faces. Faces can be overlapping or separated by some gap. So that is again one important thing. If the two faces are separating by gap, you can actually unite those two faces. So for example, if you talk about virtual unite, This is the virtual unite. If you see, this is phase 1, this is phase 2. If you say virtual unite, the shape of the face depends on the critical points that you have given on the boundaries. That is true. We will see what is the critical point. So it creates this face by uniting it. Now if you say these are the two faces, and now you want to unite them, and if you say if we have a virtual unite, now the geometry which you want to the geometry which is going to be created, it depends on what are the critical points that you have given. For example, I will select these two faces for unite operation, and now I have given A, B, C, D, E, F. These are the points which I have given as a critical points. Now what Gambit does is, whenever the new face is going to be created, the shape of the new face will be such that these edges or the boundaries of the face are going to pass through these critical points. So that is the effect of critical point. Now if I don't give critical point, something like, let's say if I don't give A, then Gambit might connect this from F to B, because there is sudden change in the slope of these edges. Gambit doesn't have information that I have to pass this edge through this particular point A. So Gambit might create a face or in such a way that the boundary of that face is from F to B. Let's have a look at these two operations. Now I'll delete this face. I want a circular face, for example. And now I'll go for creating a circular face of radius, let's say 4. And okay, I'll delete this face and I'll create a rectangular face of this. Fine. Now I'm going to do a unite operation. So go to unite and activate virtual unite. Now if I give this face, and this face, so let's say I'm going to give these two faces as a unite operation, and in this case it will ask me what are the boundaries. So it will ask me, for example, let's say I'm going to give this as the boundary point. Let's say I'm going to give this as the boundary point, then this as the boundary point, this as the boundary point, this is the boundary point, and this is the boundary point. So apply, and we see the face which is created is this. Why it has not captured the circular is because you don't have given any boundary point on this circular edge. Now what I'll do is I'll give the circular point as the boundary point. Again, which faces you want to unite? Say let's say this. My critical points are, this is one point, this is another point, this is third point, this is the fourth point, this is the fifth point, this is the sixth point, and apply. If you see, the face which is created is this. Why it has this information? Because you have given one critical point here. But if I don't give that critical point, again these two faces, if I don't give that critical point, only one point is somewhere here, these two faces, virtual, one point is somewhere here, another point is somewhere here, and third point is this, fourth point is this, fifth point is this. Apply. Okay, these two faces, one point is this face, one point is something like this, another point is something like this, third point is this, fourth point is this, and fifth point is this. Apply. It is created this because this point is below the intersection point. So fine, again these two are edges, two faces. This is one point, and this is another point, this is third point, this is fourth point, and this is fifth point. If you see, what it has done is it has captured this. So depending on what is the edges that you have selected, it will try to have a boundary same as those critical points. All the boundaries will be passing. So the concept here is, whenever there is a change in the slope, then you provide the critical point at the intersection of the slope. That is what you do. If you provide that particular critical point, then what Gambit does is Gambit passes the boundary of the face through that particular critical point. So this is the effect of critical point. Now in this case, if you see again, if I selected these as the critical point, the boundary which is created is this. Now if I go and select these critical points, if you see A, B, C, D, E, F, G, H, I and J, you can have a look at, like, as there is a change in the slope here, but there is no point at this intersection, the edge created is this. Again there is a slope change here, there is no critical point there, so A to B, it has connected A to B again. So this is the geometry which is going to be created. Now again, if you see here, why it happened is because this is the end point of the edge, and you have not selected that particular end point as the critical point. So A, B, C, again D, E, F, G and H. If you see, the face which is created is something like this. So you can always see what is the geometry that you want to create, and depending on that you can say what are the critical points. And what Gambit does is it passes the boundaries of this particular edges faces through the critical point. Now if there is a you can say a gap between two faces, a real unite is not possible, so you can say unite with the tolerant values. So what it does is it tries to create the face in the it tries to unite the face between which there is a gap. So real is not available, so real is not possible, so you can go for virtual. So the tolerance value must be greater than the width of the smallest gap between the face boundary edges. So whatever the smallest gap, the tolerance must be larger than that. The face with very large gap can be virtually united, but can create a problem during meshing, because when you see virtual unite, there is no, in fact the unite operation is done only for closing the gap. There is no geometry in between. So if the gap is more, then definitely the face the mesh between that will be of very large size. So these are the unite operations, unite face operations, real as well as virtual unite. Then this is a subtract operation, performs a Boolean subtraction involving two or more faces. All faces must be coplanar. Target face, like source face, and tool face is the face to be subtracted. So A minus B will be this. So this is the target face, A is target face, B is tool face. This is the geometry which is created, and B minus A will be this. So this is nothing but subtract operation. Subtract operation depends on if the face is intersecting completely or not. So in this case, let's say these are the two faces, cylindrical face and rectangular face. When you say subtract face, and let's say target face is face 1, which is rectangle, and tool face is face 2, which is cylindrical, then what it does is, first is it deletes the tool face, in the sense like the cylindrical face will be deleted, and what it will do is it will subtract this particular cylindrical face from this rectangular face. But right now if you see, there is no overlapping region, there is only a one edge, you can say intersection is a edge between these two faces. So it's kind of, you are splitting a face using that intersecting edge. That is the only thing it will do. Similarly, if your target face is cylindrical and tool face is rectangle, it will split that one face into two faces. Similarly, in this case, as the faces are not completely intersecting, it will create a dangling edge in between, which is definitely not good if the meshing is considered. So again, this is subtract real face operation. Retain does what? Retain retains the original faces which are there. So you have retain target face as well as retain tool face options. Boolean intersect operation does what? It intersects the edges, and the remaining geometry will be nothing but a common face in between the two faces. A retain operation retains the original faces which are there. Connect faces, there are the connect faces does connect the volumes to each other. There are different connect operations available. We have seen these operations in detail in virtual geometry as well as edge connect operation. So face connect operation does what? It connects the volumes. So there are different connect operations available: real, virtual, virtual, real, virtual. In virtual there are virtual forced, virtual tolerance. In and again there is something called as real and virtual tolerance. So this is nothing but a connect operation. So if you go to face connect, this is connect operation: real, virtual, virtual tolerance, and real and virtual. So real connect does what? If there is no gap between the faces, or if the gap is less than 10 raised to minus 6, it deletes one face, and it does the reconnection of volumes so that the volume will have a common face in between. Virtual forced will not care about the gap in between. It will always do the connect operation. Virtual tolerance is nothing but if the gap is less than the tolerance that you have provided, it will do a connect operation, else it will ignore the connect operation. And real and virtual tolerance, if the gap is less than 10 raised to minus 6, it is real connect. If gap is between 10 raised to minus 6 to the value that you have provided, tolerance value, then virtual connect. And if the gap is more than the tolerance value, it will not do any connect operation. There is also something called as T junction, which will have a look at it, the T junction operations. So this T junction option does what? Let's say you have two faces, and now these two faces can be connected only when they have a same topology. But right now if you see, this particular face is made up of different edges. Like there is a vertex E which is not on the this particular edge, or vertex B is not there on this particular edge. So in this case the connect operation cannot be done. So what we can do is we can activate T junction. In that case what it does is it does the splitting operation. It means it will project this vertex on this edge, it will do a split operation. Similarly it will project this vertex on this edge and it will do a split operation, and then it will do a connect operation. So that is the effect of T junction on the face split. If this is the case, then you have to activate T junction here. So if you say here, there you have to activate the T junction. So the T junction is available in virtual tolerance and real and virtual tolerance. So you can activate T junction. Similarly in this case also we cannot do a split operation, because we cannot do a connect operation, because this is the face and this is the face. The topology of these two faces are different. Or what it does is, basically what we have to connect is only the overlapping region. That is what we have to connect. So what it does is it splits first all these two faces to using these edges, and then it does the connect operation. So this is the connect face form. This disconnect operation is exactly reverse of this connect operation, as connect operation connects two volumes. Disconnect operation disconnects two volumes. So disconnect operation means whenever there are two volumes sharing a common face, it will create one copy of that face at the same location. It will assign that face to one volume and it will assign another face to the original volume. So that is what disconnect operation does. Now at the time of disconnection, you can always provide what you want to disconnect. Do you want to disconnect the lower topology also? In the sense, do you want to create the copy of edges as well as vertices which are forming that particular face? So there are operations like face plus edges and vertices, face only, and face and selected edges. So face and edges and vertices means it will create a copy of face as well as edge and vertices. If you say face only, it will not create the copy of edges and vertices. In fact, disconnection will not be done for the edges and vertices. Only the face will be disconnected. It means the edges will have a common end vertices, something like that. Or you can do a face with the selected edges. These are other operations on Gambit. Change the color of the face, change the label of the face, move copy operation, repositions the face or aligns the face. These are other operations. This is again a split face operation. What it does is it splits one face into two faces, splits an existing face into one or more real or virtual faces. Split operation fails for bad geometries, yes, which are not passing through the geometry check, or operation is aborted if the geometry check is not good. If only two entities are involved, geometry smooths or heals this particular faces and try to repair it for splitting operation. So let's see what are the different split operations that we can do. Split operation needs the target, the face which to be need to be split, and the split type and the split tool. So there are different split types as we have seen in edge split. Similarly in face split there are different split types. So here if we go split face, this is the target face, and this is the split width split type. Face real, it means if you have two faces which are intersecting with each other, you can split these two faces, you can split this one face with another face, that is nothing but face real. So you have face virtual. If you have one virtual face, you can split one face into two faces using that virtual face. Edge virtual, vertex virtual, and location virtual. So we'll have a look at the split operations.